So on number one, what we need to do is just do the math. And whenever you have math that you could do on a fraction, do the numerator, then do the denominator, then worry about dividing or simplifying. So 2 plus 1 is 3, and 6 plus 4 is 10. And could you do anything with the 3/10? No, you can't. So that's your answer, simplifying. Number two, on top, I have 3 take away 5, that's -2. On the bottom, we have 2 plus 3, which is 5. And there's also nothing to do, so that's my answer. And the next one, 5 plus 3 is 8, and 4 minus 10 is -6. And on this one, there is something you could do. You could reduce. And not only that, you could take the negative sign and put it either on the middle or up on top. Makes it look nicer. So I'm just going to say that my final answer is going to be -4/3. Okay? So you're probably thinking, why are we doing these simple math problems? Well, we're going to dive in to section 3.3. Whoops, that's a mistake, guys. Change that for me. That's 3.3. Slope, also known as the rate of change. So what is slope? Slope is a steepness of a line. It tells you the direction your line is going. You describe your slope with a fraction, and the fraction is rise on top, run on the bottom. The rise is positive if from left to right the line's going up. The rise is negative if from left to right the line's going down. The run is always positive. So slope is represented with the variable m. So whenever you see the letter m, we're going to be talking about slope. Now once again, what is slope? It's a fraction. The number on top is the rise. The number on the bottom is the run. When we focus in on rise over run, if from left to right your line's actually going up, it's an actual positive rise. If from left to right your line's actually going down, then it's a negative rise. And we also need to memorize this formula, but let's not talk about that formula right now. Let's first really understand what slope is, which is simply the steepness of a line. So if we take a look at this blue line right here that you guys have on your paper, we want to describe how steep this is. So would you say this is pretty steep? Is it going up or is it going down from left to right? It's going down, so it's pretty steep. Imagine if it were like a water slide, you'd be going down that thing pretty fast. So the question is, what is the exact steepness of this line? Well, to describe your exact steepness, you're going to be describing the slope of this line. And we just said that the slope is a fraction, and the number on top is the rise, and the number on the bottom is the run. So what we need to do is pick 2 points. Let's go with this one right here and this one over here. From here to here, and I'm talking about from left to right, I asked you earlier, is it going up or is it going down from left to right? Down. So I know I have a negative rise. Now, how many levels did it actually go down from this point to this point? It went down 2 levels, right? So that rise is going to be a -2. And the run is talking about how far do you go from here to the next dot here. How much do you run from here to here? 1. So ladies and gentlemen, this is our exact steepness of this line. This is our slope of this line. M equals -2/1. Now you could also say that M just equals -2. But in this section, it's a good idea to show your denominator because the denominator represents the run. So once again, when you want to find the slope, you first have to ask yourself, from one point to another, do I go up or do I go down? Oh, I'm going down. How many units did I go down? I went down 2 units. So that's my rise. It's a -2. Now my run from here to here is 1. So what's my fraction going to be? -2/1. Rise over run. Get it? Now, you didn't have to use this point and this point. You could use this one over here and this one way down here. Check it out. If I would have gone from here to here, that would have been, let me see, 1, 2, 3, 4, 5, 6, right? So that's a -6 as my rise. And then I would have to run 1 unit, 2 units, 3 units. So that'd be a +3 as my, -6 is my rise. I went down 6 and I went 3 over. So my slope would be -6/3. But that could be reduced, and if you reduce it, it'll become -2/1, which is the same thing we had before, -2/1 up here. So it doesn't matter which points you use, you just have to find your rise, which might be positive if it's going up, or negative if it's going down, and your run. Once you do rise over run out of any points on the line, you'll be able to find that slope. Moving on to our next one over here. What would the slope of this guy be? Anybody? 1/2. If you pick this point and this one, how much do you rise? 1. How much do you run?
2.
There you go. And did you rise up or did you rise down? Up, so that's positive. Okay, so get something straight, guys. We're gonna look at lines like we read sentences from left to right. Once again, we're gonna look at lines the way we read sentences from left to right. Okay? So when you look at this dot and this one, yeah, you're gonna go up. So that's a positive rise. How much do you go up? You're gonna go up 1 unit. How much do you run? You run 2 units. So what's your slope? Up 1/2. Rise over run. The slope is 1/2. You got it? Okay. So right off the bat, we should be able to look at a line and see if it's a negative slope because from left to right it's going down, or a positive slope because from left to right it's going up. Okay? So down here, we have 2 lines. Which one has a negative slope and which one has a positive slope? The red one has a negative slope, right? So this one's negative and this one has a positive. Whoa. Positive. Okay. Now, if you wanted to be specific and give me the exact slope, well, then you'd have to pick some points. Like this one's a nice point, not a nice point, not a nice point, not a nice point. Right here's a good point, right? So if you actually wanted to give me the specific slope, I would use these 2 points. And what would the specific slope be? Okay, when you say 1, you're telling me that you're going up. -1/4, right? So the specific slope right there would be -1/4. But I'm just wanting you to identify negative and positive, right? So this one is negative, the red's negative, the blue's positive. Why is the red negative? Because from left to right it's going down. Why is the blue positive? Because from left to right it's going up. If you look at this next one, what's the steepness of this line? How steep is that? If you were on a skateboard right here, would you go that way or would you go this way? You wouldn't go anywhere, you would stay right here, right? Why? Because this is not steep. This is the opposite of steep. This is completely and utterly flat. So when I say, what's the steepness? What do you say? It has no steepness. That means that the slope must be what? 0. Okay? Now, when we look at this next example over here, it has a line that's perfectly up and down, perfectly vertical. How steep is this? This is like the steepest it gets, right? It's not even, there is no steepness. In other words, it's so steep. I shouldn't say there is no steepness. Over here, there's no steepness. But right here, we have to say that our slope is undefined. And why am I writing it if it's already down here at the bottom of our graphs? This is an undefined slope when it's vertical. This one over here is the slope 0 when it's completely flat. And of course, we have the positive slope. Whoa, I should probably do this in blue. We have the positive slope, that's in blue, going this way. And we have the negative slope, that's in red, going that way. So these are easy questions that will also pop up on tomorrow's quiz. And the one final detail about slope that we need to learn is the slope formula. So I was debating whether to have you memorize this tonight or wait till next week. I decided tonight. So I apologize. This is your homework right here. Memorize m equals y2 minus y1 over x2 minus x1. y2 minus y1 divided by x2 minus x1. Of course, all this is going to be on the videos, so please watch these videos or else you're not going to do well on tomorrow's quiz. So this is the formula that will give us the slope, the rise over run, without actually having to see a line. Like up here, if I said, what was the slope of this red line? Well, you had to see it so you could count. Oh, I went down 1, I went over 4. What if you didn't have the line? Then you wouldn't be able to count. So with this formula, as long as they give you 2 points, you'll be able to use this formula to find the slope without having to visually see the line. Let me give you some examples, or go over some examples here. Number 1 up here, it says find the slope of the line that passes through those 2 points. So one option is to actually graph them, but that gets ugly because if you don't have graph paper, you're going to make a mistake on the spacing and you're not going to be able to count how much you rise and how much you run. So the better option is to recognize that both of these guys are actual coordinates, which are x values and y values. X values and y values. Now, how am I going to, like if I tell you, look at x, which one am I telling you to look at? The 3 or the 5? Who knows? Because they both say x on them. So what should we do? Well, let's call this coordinate right here our first coordinate. So I want to put a little 1 right next to them. And let me call this coordinate my second coordinate. So I want to put a little 2 right next to them. And that is where your y2s and your x2s and your y1s come from. So once again, the slope is this. Slope equals y2 minus y1 over x2 minus x1. Now, the first thing to do when you want to apply this formula is to rewrite your formula, but without the letters. So you're going to do the fraction bar, the subtraction, and you're going to leave the blank spots. Now, what belongs on the top left? The y2 value, which happens to be 6. Now, what belongs on the top right? The y1. What belongs up here?
2.
The 2. So let's put the 2 right there. What belongs on the x2 spot? 5. And what belongs on the x1 spot? 3. Okay. So this is our slope. All we need to do is simplify it. And we have 6 minus 2, which is 4. And we have 5 minus 3, which is 2. Could we reduce? Yeah. It becomes 2 over 1. I know you could say, oh, the answer is 2, which is correct. But for the sake of showing your rise and your run, we're going to leave it as 2 over 1. So that was just one example, and we'll do another video covering more of these.